So we're going to get started. So I'm Julia Carson. I'm the curriculum developer who created this course. And this microbit course has been a long time coming at CodeHS. So I'm really excited to share it with you now. So you can begin to get your students excited about physical computing. So we're going to take a look at what we're going to cover today. We're going to start with an overview of the course, who it's for, what it covers, and some important information to keep in mind when bringing this course to your students. Then we'll take a look at exactly where you can access all the needed materials for the course. We'll give you some information about our teacher testing group, so you can decide if this is something you're interested in joining. And we'll end the webinar with a Q&A. So don't worry, all your questions will be answered by the end of this event. All right, let's get started. We're going to start by doing a deep dive into the course overview. The Physical Computing with Microbit course provides a highly interactive way for students to apply programming concepts to physical devices. This course is meant to refresh and apply basic programming concepts in a physical environment. I'll talk a little bit more about what that means in a bit. Throughout the course, students will test and run programs using a computer simulator, as well as connect circuits to run programs on their physical microbit devices. This course was designed to be taught over the course of one semester to middle school students, though it does not mean that it can't be used for high school students as well. For example, if you already have access to microbit devices, are thinking of bringing a physical computing course to younger high school students, such as freshmen or sophomores, or have a shorter time frame to fit the content into, this course could be a great fit for high schoolers as well. The microbit course is broken into 3 modules. In the first module, students learn the basics of the device by controlling the on-screen LEDs, as well as learning how to attach and control external LEDs and use variables to control their programs. In the second module, students apply control structures to their programs, along with sensors and additional components. They'll use temperature, light, and distance sensors to detect attributes of an environment and have their programs make decisions based on this information. In the advanced microbit module, they will put all of these parts together. They will research and teach their peers about an additional sensor that hasn't been covered in the course, follow step-by-step directions to complete a more advanced system of their choosing, and then develop and present a final physical computing project. We wanted to have a strong discovery learning focus in our physical computing courses, so we encourage students to hypothesize and test what commands do on their own through the use of what we call explorations. These step-by-step documents include diagrams, starter code, and questions to guide students to learn about new commands and how they are applied in their programs without being directly told by their teacher. Each lesson in the course contains an exploration, so students are constantly exploring new commands to add to their physical computing toolbox. I previously stated that this course is meant to refresh programming concepts for students. What this means is that basic programming concepts, such as loops, functions, if-else statements, and variables, will not be taught from scratch in this course. Students should have already seen these concepts previously, so they are aware of how they work before they use them with their microbit. There are quite a few CodeHS courses that provide this prerequisite information to students, as noted here. One important thing to keep in mind, though, is that our Intro to Programming with Carol course does not include any information on variables. So if you're going to use this course as your prereq, you'll need to supplement with some information about variables and parameters before students see these concepts in the microbit course. There are a few ways these prereqs can be implemented. You could have students join your class after as the first semester of your course if it is a year long. Another option is to have students learn these foundational concepts concurrently as they take this course. This could be provided during another class period if your students are lucky enough to have 2 periods of computer science, or could be threaded into the intro programming course. Let's take a look at an example of how this could work. let's say you were teaching the Intro to CS in JavaScript course. The overall layout of the course content is shown here, with each concept that students will need to know in order to be prepared for the microbit course noted in their respective module. Now here is where we could thread the microbit lessons into the course to keep students engaged while still providing them with the foundational information they'll need to be successful. This will automatically show students how to apply the concepts they're learning and will make these foundational topics immediately relevant. Now, in order for students to build physical systems, they're going to need some materials. CodeHS.com/microbit_materials will give you the entire list of materials used throughout the course, complete with suggested links, amounts, and important notes. Though it may seem that there are a lot of materials required for the course, the average price for each item is below $5, and students are encouraged to work in pairs or groups of 3 rather than individually, which will minimize the number of each item you'll need for your classes. Throughout the course, students will work with LEDs, internal sensors, such as the temperature and light sensor, micro servo motors, and external sensors, such as an ultrasonic rangefinder that measures distance. They will combine these components with various programming concepts to complete engaging exercises, some of which are shown here. All right, before we move on to how to access our materials, we're going to see if we have any questions. All right, maybe we're going to move on for a bit.
Sorry, Julie, we have a few questions.
No problem. Sounds good.
So the first one is from Susan. She says, when you say 1 semester, how much time are you expecting? So 5 days a week for 45-minute classes?
Good question. So our content is broken down for 5 days a week for an hour long about each lesson. So some lessons, because of those explorations I talked about, you would do the exploration one day and then students would complete some exercises the next days. So the semester is expecting 5 days a week, about hour-long classes each day.
Great. And then Sandra asks, will we have a link to the recorded webinar for reference? So yes, we will be sending out a recording to this webinar to all of our attendees. Let's see. Are there materials already laid out for the integration of the Intro to CS JavaScript and this microbit course?
Good question. So for the JavaScript portion, that course doesn't require any materials. Students just need access to the internet. So because this is our first physical computing course, this is the first course that we actually have a materials list for. So you'll find all the materials you would need in that materials section. And I'll share that link out again.
Great. We have another question. How do I find the microbit course on the website? So we will be sending out directions on how to access the beta version of this course. We have a question. So will these activities be in together?
Can you say it again? Sorry, you cut out a little.
Sorry. Will these materials be for just JavaScript or Python, or one or the other?
Perfect. So the actual microbit is programmed using JavaScript. The materials are used for that. There is a way to use microbit using the Python language, but our course is teaching using the make code editor, which is all in JavaScript. But the materials, the physical materials that you'll actually need, obviously can be used when programming in any language.
Is all of the programming text-based, or is there an option to toggle on a block-based view?
Great question. So the make code editor, which is provided through microbit, does have access to blocks, text and blocks, or text. So students are able to use blocks to code their programs and then see the text versions. But in our course, because we are expecting that students already have knowledge of those foundational topics, our course is fully taught in the text version, because we want students to be able to advance their knowledge. They'll already have that knowledge of for loops or if else statements that they got from the intro course, and then they're going to apply them to microbit. So we're teaching the course in full text.
Great. And then we have a question, does any microbit work? And I think they're referring to maybe there's different versions of the microbit.
Good question. I would think that all of the microbit versions would work. I'm not sure how far back you might have a microbit from, but they all should, if they can use the make code editor, then they should be fine.
Great. Is this only geared for programming, or can it be implemented in a computer networking course?
This course is definitely focused on the programming aspect of physical computing.
Great. And then just to answer somebody's question, so somebody asked about the cost of this course. So this course is free, the curriculum is free. The only purchase would be the materials, so the microbits and the materials list. And I think that's it, Julia, so we can keep going.
All right, and if you have more questions, keep putting them in the Q&A, and we'll still be able to answer them as we go on. So let's take a look at how to access materials, since that was a lot of questions about that. So the course is being released in beta right now, and you can use the following link to access it. It's codehs.com/microbits/start. And as Evelyn noted, all of our content, all of our curriculum is free. So you should be able to access all of the student materials as well as the teacher materials there. You can join this section using this class code. So 82727 is the code you'll need to join that beta. And a quick note about the materials is that sample lesson plans and handouts have been completed for the first 2 lessons of the course, with more being added in the coming weeks. So all of the student-facing content should be there for you to access and test, but the lesson plans as you go through the course and handouts will be added as we continue building out those portions of the course. You can view the course syllabus by going to codehs.com/syllabus/4065, or directly from the microbit marketing page at codehs.com/info/curriculum/microbit. These items note much of the information being shared with you here, so they're really good resources to start with. There's a lot of links and things there where you can access different parts of the course. All right, I think I saw a few more questions come in. Do we want to answer those before we move on?
Yes. Can you hear me?
Yes, now I can.
Sorry about that. Yeah, so we have a good question here. How would you modify the course for distance learning, or how might you suggest, teaching this course as a distance learning course?
That's a really good question. We have obviously at CodeHS been thinking about this in respect to all of our courses, but this specific scenario gives some options. So we really want with this course students to be able to learn how to take a physical device and see something, see how text on the screen is going to make a physical device move or sense its surroundings, things like that. That is the part of physical computing that is so engaging and exciting. But on the Make Code Editor site, where you saw some simulations, students can technically go through, I would say, 90% of the course using just the simulations online. So if they don't have access to those physical materials to build those circuits, they can do all of that online and then test their code directly there. So that is a good option for students. The external portions, like we teach them how to build a circuit using an external LED or like I said, the ultrasonic rangefinder, which is a really cool distance sensor, those wouldn't be available to the students if they were only using the simulated version, but the majority of the course would be available that way. And I think all the explorations, students can fill them in and go through all of that content directly online instead of having a physical handout with them. So there are definitely a lot of really good options if, you know, we're still in a state where you're going to have to bring this course to students while they are at their own respective homes.
Great. A question, if I want to enroll in the beta course, but I already have an account on CodeHS as a teacher, how should I proceed to enroll?
Yeah, so when you go to that link, it will prompt you to sign up, or you should be able to just log in. If you already have an account on CodeHS, you should be able to just join a section, and that's where that CodeHS, where that class code comes in. And that class code 82727 will be entered the same way that your students will enter their class code to join your class, because we are having the beta group go through a section like that.
Great. Do you think that this is about distance learning again? Do you think students could handle a physical device at home without, you know, physical supervision, or is this something that you would want an adult to be overseeing?
Yeah, that's a really good question. So if you are able to have students get their hands on physical devices, I think that's a great idea. There are some parts of the course where it might be more difficult, especially once they start using a breadboard, which is a way to build more complex circuits. There's a lot of scenarios where students just have plugged one wire into one port that's one off from where it should be, and their program won't run in that case. So it would be a little bit more difficult to debug as a teacher virtually, but that still could happen, you know, having students video their device to you, taking images and sending them to you to help them debug their code. There's one scenario where they would need to add extra power. The ultrasonic rangefinder doesn't run on just the power provided from the computer, so they need an external battery pack for that. And the only, I wouldn't say danger to the student, but danger to the device is that if students plug up the external battery pack incorrectly to the microbit, they could short out the microbit and the microbit will die. So that's the one scenario where I think you would want either to avoid or just be extra cautious in how you give that information to students before they start that part of the course.
And Julia, do you know if the MakeCode coding environment, is that compatible with iPads?
I'm not sure. I haven't tried, but it's a very built out platform, so I would assume that they have thought about using it in many different scenarios.
Got it. Yeah, we have a few questions just on the materials. So in terms of the set of materials, do you have a rough estimate for what would be the cost for one station? So like one kind of kit that, you know, group of 2 or 3 students could use?
Yeah, so there are a bunch of different ways, and on that materials list, you'll see a lot of notes, a lot of links. There's a bunch of different ways to get those materials. So for example, there are kits that are fully developed that have a bunch of sensors that are the sensors that we use in the course, plus additional ones, which students will be exploring in the 3rd module of the course on their own. So a kit like that would come with the microbit, with a bunch of wires and resistors and things like that. And that initial purchase could be, I've seen kits from like $40 to $70 that have all of that material in it. And then you could supplement with multiple microbits. The microbit device itself is probably the most expensive part, which is still, I think, around $15 or $20 each. And those, you know, again, you can use that for 2 to 3 students. All of the other materials are pretty cheap on their own, but it's good because if you're buying a class set, you know, you can't really buy like 3 wires for for your students to use for one group, but you would be using it with multiple sets of students. So, you know, a set of 100, 200 wires could be $5 to $7, and that would be more than enough for every student in your class. So while I don't have a specific number that it would take, because so many of these materials are not sold individually, you can't buy 3 resistors even though you only need 3 resistors per group. I would say that the materials are built in a way that would be really helpful for you to provide for your whole group of students.
Great. So we did get some answers. So MakeCode is compatible with iPads, so students can use iPads for this course. Let's see. We had a question just about, as a teacher, kind of debugging the simulated environment versus debugging the physical environment. Basically, I guess, when would it be appropriate or more helpful or easier to debug the simulation versus like physical circuit?
Good question. So in this course specifically, students aren't building out the device and the connections. Students can use, as you saw in one of the simulations, students can simulate a servo motor that is connected to the microbit and actually program that simulation. But students are not actually adding that servo to the microbit and making those connections. Those are done automatically as soon as the student writes a line of code or a command that includes the servo motor. It will automatically get added. So the debugging of the actual connections on the simulation, you would not need to do that in this course specifically. You would need to debug student code, and in all of our exercises, students will be copying and pasting their code from the MakeCode editor into our system so that you have a running tally of that and you can revisit that and give them information and feedback. So debugging their code is still for sure possible for you as the teacher, but you wouldn't need to debug any simulated connections.
Great. We have a question, and I believe this is in reference to our Python 3 course. Would it be possible to use the Python 3 course instead of the Intro to Computer Science and JavaScript course with the microbit course?
Great question. So yeah, I think this actually is a really good idea. A lot of students are usually just exposed to one language, and it is helpful for them to see where one language is stronger than another. So them exposing them to both Python and JavaScript at the same time, I think is a really good idea. You would still for sure be able to find those stopping points in the Python course where you could then move over to microbit and use that. The only addition you would need is just to show students that the syntax is different in these languages, but that's a really good thing for them to learn anyway. The way that a for loops works is still the same in Python or in JavaScript. We're just going to use a little bit different language to get there. So if you have any more questions specifically about like where in the course would I stop and add the microbit content, you can definitely reach out to us at hello@codehs.com and we can get someone to give you more specific information about how to thread those 2 courses together.
Great. I think that is it for now. There's a few questions I'll answer just by typing answers, but I think we can move on.
Perfect. Yeah, and we'll still have more time at the end, so keep those questions coming. Okay, so we're going to take a look at our teacher testing group and how you can get involved in this. Because this course is so much different than our other courses that we offer on CodeHS, like I said, with, you know, we don't have materials, physical materials for any of our other courses. We want to be sure that the materials we're providing for teachers and students are highly effective, informative, and fun. In order to be sure of this, we'd like to connect with teachers that expect to use this course with their students on a more individual level and give you a chance to be heard. We understand that commitment levels and available timeframes may vary greatly depending on each situation, so we have multiple ways to get involved. Testers can be given access to our feedback system where comments and suggestions can be left on individual items as you go through the course, or you can choose to be a part of phone calls with the CodeHS developers and other testers. So if you're interested at all in getting involved in this way, please fill out the Google form, and you can find it at codehs.com/microbit/testing. It will just ask you a little bit about what you're interested in doing, where you're, how much time you have, and things like that. And I thank you in advance for considering joining this group to make this course as great as possible, because that really is the goal here. We want to make sure that we are testing these materials enough so that we know, especially in these new settings that we have, like distance learning, that we're providing everything that you need to be successful and for your students to be successful. So we're going to move on to the end and see if we have any last questions to answer.
Great. Are we planning any other computing or physical computing courses after the microbit?
Great question. So we actually, I'm just going to switch here really quickly. You'll see next Thursday, May 21st, we're going to be doing the same webinar for our physical computing with Arduino course. So you heard me say at the beginning, this course was designed with middle schoolers in mind. The Arduino course is a little higher level in a few different ways. It uses a different language. It requires a lot more connections and building of circuits. So that might be a really good next step after the microbit course, if students started there and then now are learning to use a little bit more of a powerful device. But they also could start right there if you have students that already, are in a robotics club, or you think just are at a next level, or maybe are in high school and are ready to build these more complex circuits. That physical computing with Arduino course is also being launched at the same time as our microbit course.
Great. We have a question, just how soon can we get started? So today, right?
Right now, yeah. All the materials there, so we're ready to get your feedback, and it really will be so helpful for if you can join that testing group. So as you go through the material and you notice, I really wish I had access to this, or this is a material that would really make my students understand this concept better. All of that information is taken really strongly from our curriculum team. And this is why we're launching a beta now, so that we can make sure our course is as great as it can be when we fully launch it in July.
Great. We have a question. If I wanted to use CodeHS with my class, is the CodeHS classroom free to use, or would I need to pay for a subscription? So this entire course and the setting up a class is totally free on CodeHS. We do have a pro plan that you can get in touch with us about that would just include stuff like student tracking, gradebook, and just kind of those more advanced tools. Julia, I'm not sure how familiar you are with the lesson resources that are on the microbit.org website, but we have a question, just how is this course different or similar to the lesson resources on the microbit website?
Yeah, so I have looked at a few of those resources, and they are great. And I think our course specifically is designed for students to start from scratch and learn specific computer science concepts as it applies to a physical device. We're more focused on the actual concepts, like how do I apply if-else statements versus how do I just light a heart on my microbit, which you can do as well. And the main difference, I would say, is just the platform that you're delivering the content to students. So all of the microbit resources you can use with your students offline in another way. but we have step-by-step, having students start from the beginning, click here, explore this, what does this command do, and then use it to write some of their own programs. And I think that our course for sure quickly covers a lot of content and allows students to build really advanced and exciting programs that they otherwise wouldn't be able to do. I haven't seen any microbit materials that include external components, how to build a circuit outside, and what that means, and how to use external sensors with the microbit, which there's a lot. The microbit is a really powerful device, even though it's very beginner friendly.
Oh, this is a good question. So it was mentioned earlier that this course uses the MakeCode environment. So how is MakeCode integrated in CodeHS, or do students need to switch back and forth between the two?
Good question. So this course has been a long time coming, with us trying to determine the best way to make this happen. And we have decided to have students write and test and simulate their programs on the MakeCode editor separate from CodeHS. But students will have all of the information that they need and the step-by-step directions in CodeHS. So they'll be, especially like, for example, they're going to start with an exploration, and that document could be printed off for them if they're in a standard classroom. They can have that document with them, and then they're going to be on MakeCode going through and testing out the commands. And all of that information is being saved onto that document. So whether they're physically handwriting the answers onto the document or using it online, that content is given to you as the teacher that way. Then students will complete some examples where we will give them code that they will copy and paste into the MakeCode editor to see what happens. And then they'll be completing exercises where students will be tasked with a specific set of things they need to do, and then we'll go into the MakeCode editor, write their code, and then paste it back in. So it should, though they will be going back and forth between the two systems, all of the information that you will need as the teacher should be logged in your CodeHS account so that you can access what students are doing and when.
Great. We just have a few questions related to Raspberry Pi. So first, can you just compare the Raspberry Pi with microbits and talk about whether Raspberry Pis are appropriate for middle school students? And then we have just a question about, do we have plans to create a course using Raspberry Pi?
All right, good question. So I would say microbit as a device is much, it's less advanced than a Raspberry Pi. A Raspberry Pi is also designed to do completely different things than a microbit. I would say Raspberry Pi is closer to Arduino in the level that it expects, but it also is very different than Arduino on its own. So in general, I would say that as devices, they are very different. I would steer away from using a Raspberry Pi with middle schoolers, just as I would steer away from using an Arduino with middle schoolers in this scenario, because I think there are so many other concepts we want them to learn, and we want to make sure that they're not getting confused or frustrated by the use of breadboards so quickly to build circuits. And as for plans to develop a Raspberry Pi physical computing course, that is in the works. Our third device that we're looking at using will be Raspberry Pi, but we don't currently have a time frame for when that will be available.
Yes. Can the students use a Chromebook?
Yes, all of our content is accessible on Chromebooks.
Great. Just a clarification. So I think I've had a few people write in just asking, so after entering the class code, you are joining the class as a student. So you will be going through like the student facing course. Yeah, that's just a clarification there. Will there be advanced microbit classes, like how to create make code libraries, use CS algorithms on CodeHS?
So that would be a great next step. And this is definitely the first of many physical computing / robotics things that I would like to see on CodeHS. But this is our first start, and definitely seeing how this works and what's next for students who are interested in this type of programming.
Great. Just because we had a few questions on this, so we are going to be sending out a recording of this webinar after. You should receive it today or tomorrow to anybody who RSVP'd, so you will be getting a recording. What is the third device? So you talked about microbit. Raspberry Pi is not right now, but something that we will have in the future. What's the third one, Julia?
Yeah, the third device is Arduino, which as you'll see on this slide, on Thursday, we're going to be talking about that course, which is more geared towards high school students. The Arduino is a little bit more powerful of a device. So join that webinar if you're interested in seeing how these two courses compare. And you can go right to codehs.com/webinars to sign up for any of those.
Can you talk a little bit about what projects students will be creating in this course?
Yeah, so students are using a lot of different components. They're using on-screen LEDs as well as buttons, different sensors that are built into the microbit. They're also able to add external components such as servo motors, LEDs, and then external sensors like the ultrasonic rangefinder. Those are the components that we specifically are teaching students how to use in the microbit platform. But in the third module, as you'll see, the first two are more structured to actually teach students how to use these devices and learn what commands can be used and how they're used to build programs. In the third module, it's a lot more exploratory, where students are going to complete some challenges. So one of them is building a digital watch using their microbit. So finding a way to write the code that their microbit will actually keep track of time. But then as well, there's an add-on where students can then do the engineering side of things, where they would build a way to have their actual microbit sit on their wrist and wake when they move their wrist, the way that a lot of smartwatches do. Then they're also building an inchworm, which is a little cardboard device. So a lot of basic materials there, where they are building a cardboard inchworm that will use a servo motor to open and close as it moves, and also uses that rangefinder to stop moving when it senses an object in front of it. So those are some of the challenges that students are starting that module off with. Then they're also going to be exploring and teaching their peers about sensors that we have not covered. So that was what I was talking about with those kits that are available that have microbits and all the other components that might be used there. Those kits have a lot of different sensors that can be used with the microbits. So in that lesson, students will be exploring how those sensors are used, what they do, how to use them in different programs, and then teaching their peers about that, so that in their final project, they are able to have a plethora of different things to use, so they can build whatever project they're inspired by.
Great. It looks like things are kind of slowing down. Let's see. We will not be issuing PD certificates for these webinars. You can get in touch with us, hello@codehs.com, if you have other questions about kind of attendance or how we're tracking stuff like that. Great. I'm not seeing many other questions right now.
Okay, well,
Oh, I guess one more. How long is the course expected to take? How many lessons are there?
there are a variety of numbers of lessons throughout the 3 modules, but one of the things to keep in mind is that one lesson, the way that most of our CodeHS courses expect one lesson to take around 1 class period, I would expect these lessons to take more than 1 class period because students are exploring those commands on their own using those explorations. So we are expecting this course to be taught over the course of a semester. And that is including the time for students to complete those larger projects at the end of the course, as well as presenting, you know, their final projects, which should take a substantial amount of time.
Great. Just a few questions about the recording. So will we have a completed Q&A with answers listed with the question instead of this question has been answered live? No, we won't. However, if you send us an email at hello@codehs.com, we can answer any questions that you have if you missed it in the recording. Great. A few people interested in joining the beta group. So I did post in the chat the link to the form. So codehs.com/microbit/testing for anybody that wants to fill that out. And just a reminder, we will be sending a recording out to all of the RSVPs. And I think that's it. Are students allowed to join the beta group? I would say send us an email at hello.codehs.com, Teresa. In general, no. But if you have students in mind, you can reach out to us and we can talk to you about that. Great.
Yeah, if there's any final questions, you can put them in the Q&A, but just want to let you know, we have these upcoming webinars over the next 2 weeks and more in addition on the codehs.com/webinar site. On Thursday, we will be talking about Intro to Computer Science in Python 3, which is an updated version of our Python course. That will be this Thursday. Then we have a Fundamentals of Cybersecurity course coming out, and that will be next Tuesday. And we're going to be talking about the second device that we have this physical computing course offered with Arduino next Thursday on the 21st. So you can go to codehs.com/webinars for more information and to sign up for the webinar.
Great. The course will be live for students in July. Just a few last questions. Julie, do you know about the hummingbirds and hummingbirds that are used with the microbits?
Yeah, I've seen Hummingbird. I've actually met some of the workers there at various events. They have a lot of materials that for sure can be used with the microbit and are great ways to extend this course. They are a little bit pricier compared to the materials list that we have for this course because we want to make it as accessible as possible. So all of our materials that we require are basic. You can, you know, get any sort of motor, any sort of servo. And the Hummingbird company has a lot of additional materials. So if you wanted to then allow your students to use those in their final projects or things like that, I think that would be a great idea, but those are definitely not needed for the course.
All right. I think that's it. So Thank you everybody for joining. I'm posting one last link to the rest of our webinars. So codehs.com/webinars, that's where you can find all of our other course beta webinars and RSVP to them. But thank you everybody for joining.
Thank you.